at a high-tech facility owned by Turkish Aerospace Industries TAI in Ankara. Turkey is building one of the most ambitious projects in the history of its defense industry. That project is the TAI KAAN, a next-generation stealth fighter designed to elevate Turkey to the ranks of modern fighter jet manufacturers worldwide. Inside this assembly line, thousands of technicians, engineers, and avionics specialists work day and night, assembling every part of the aircraft with incredible precision. From the fuselage frame, wing assembly, AESA radar integration, to afterburner engine testing, everything is done using cutting-edge manufacturing technology, previously only available to major fighter jet manufacturers. A fighter jet's journey begins in the digital design room. Engineers use sophisticated computer simulations to create an aircraft structure that will achieve stealth characteristics. The fuselage's shape is designed to reduce enemy radar reflections. Once the design is finalized, production begins cutting composite and titanium sheet metal using automated CNC machines. On the KAAN assembly line, industrial robots work side by side with human technicians. Robots are tasked with precision, drilling, and riveting thousands of points on the fuselage. Meanwhile, technicians ensure every joint meets stringent military standards. The entire process is carried out using a laser alignment system and modern digital sensors. One of the most complex parts of a fifth-generation fighter jet is the assembly of the wings and stealth structure. Unlike conventional jets, every angle on the KAAN is designed to minimize radar signature. Technicians use lightweight yet extremely strong composite materials. These materials can withstand high temperatures while helping to reduce the aircraft's weight. Once the main structure is complete, the next stage is the installation of the jet engine. The initial KAAN prototype used the General Electric F110 engine, also used in the F-16. This engine provides powerful thrust for supersonic speeds and extreme maneuverability. In the engine integration area, technicians meticulously install the fuel system, air ducts, and engine cooling system. The most sophisticated part of the assembly line is the avionics integration room. In this sterile room, engineers install the mission computer, AESA radar, electro-optical sensors, electronic warfare systems, and a modern data communications network. The AESA radar enables KAAN to detect air and ground targets at long range with high accuracy. The system can also track multiple targets simultaneously. Furthermore, KAAN is designed to have super cruise capability, high situational awareness, and modern interoperability to support future networked warfare. All electronic cables within the aircraft are neatly ranged. The total length of cables on a single fighter jet can reach tens of kilometers. Every connection must be checked repeatedly to ensure there are no system disruptions during operation. Before the aircraft is authorized for flight, all systems must undergo rigorous testing. In the test hangar, technicians run flight simulations using specialized computers. The radar system is tested using virtual targets. The engines are run at full throttle to ensure normal afterburner performance. The landing gear is repeatedly tested to ensure it can withstand the loads of a high-speed landing. The KAAN also undergoes high-speed taxi tests before it's made in flight. In these tests, the aircraft accelerates at high speeds on the runway to verify aerodynamic stability and flight control response. Turkey is currently accelerating production of the second and third KAAN prototypes. According to recent reports, several new prototypes are undergoing system integration and advanced assembly on the main production line. The latest version features several design changes, particularly in the air intakes and internal systems, which have been improved based on previous flight test data. Turkey's long-term goal is to mass-produce the KAAN and enter the Turkish Air Force inventory. By the end of this decade, the aircraft is also being prepared for the international export market. In the KAAN production facility, automation technology plays a key role. Many aircraft parts are manufactured using robotic assembly systems and artificial intelligence to increase production efficiency. Digital sensors are installed throughout the production line to monitor temperature, humidity, and component assembly precision. All data is processed in real time through a central control center. Digital twin technology is also used to create virtual simulations of the aircraft before actual air testing. This allows engineers to detect potential problems early, reducing the risk of failure. The KAAN program is more than just a fighter jet project for Turkey. This project symbolizes the revival of the national defense industry and an effort to reduce dependence on foreign technology. The successful maiden flight of the KAAN is proof that Turkey is now capable of entering a new era of modern military aviation. Several countries have even begun to show interest in this fighter jet, including Indonesia, with which Turkey has established defense cooperation. With its stealth capabilities, modern radar, advanced sensors, and cutting-edge electronic warfare systems, the KAAN is projected to be one of the most important fighter jets ever produced by Turkey. It is within this assembly line that the future of Turkey's Air Force is being built. The sounds of industrial robots, the sparks of automated welding, and the roar of jet engines symbolize the ambitious ambitions of a country striving to stand alongside the world's most advanced fighter jet manufacturers. One of the most revolutionary technologies in next-generation fighter jets is artificial intelligence, or AI. AI systems will help pilots analyze thousands of pieces of combat data in seconds. In sixth-generation aircraft, AI serves more than just a standard assistance system. This technology is capable of reading threats, predicting enemy movements, selecting priority targets, and even providing real-time combat strategy recommendations. Future pilots will no longer work alone. AI will act as a kind of digital co-pilot that can take over most of the complex tasks in the cockpit. This allows pilots to focus more on strategic decision-making. Some concepts even allow fighter jets to be flown without a pilot or in an optional man mode. This technology is being developed by various major countries in sixth-generation fighter jet projects. Next-generation fighter jets are also designed to work alongside advanced combat drones, called loyal wingmen or collaborative combat aircraft. This concept allows one main fighter jet to control several companion drones simultaneously in the air. These drones can carry out various dangerous missions, such as reconnaissance, electronic warfare, missile attacks, and even act as decoys. To deceive enemy radar, the pilot only needs to issue the main command, while the AI within the drones will carry out the mission automatically. This technology makes air combat power far more flexible and deadly. The United States, Europe, and even Turkey are actively developing loyal wingman systems to support next-generation fighter jets. Several escort drone concepts have even begun flight testing, while fifth-generation jets already possess stealth capabilities. The next generation will take stealth technology to the extreme. Aircraft fuselage designs will be sleeker with a very small radar signature. In addition to radar, aircraft are also designed to be difficult to detect by enemy infrared sensors and heat-seeking systems. New materials based on composites and metamaterials will be used to absorb radar waves. Some future aircraft concepts even feature a smart skin structure filled with digital sensors. This new generation of stealth technology allows aircraft to remain elusive, even against modern low-frequency radars, which are now being developed by various countries.